Let's take a look at parabolas more closely and parts of a parabola. First thing we're going to look at is something called the axis of symmetry. We're going to abbreviate that AOS. Symmetry is something that an object possesses if it can be reflected over something like a line. You can think of a heart having symmetry because you can divide it down the middle, approximately, and it's the same thing on both sides. Parabolas have symmetry. How we're going to label symmetry is I'm going to use red each time we have symmetry, and we're going to use a dashed line. So as I look at my parabolas, that was a horrible line. Let's see if we can make that better. There is my axis of symmetry. I'm going to label it AOS. This parabola also has an axis of symmetry. In fact, every parabola has an axis of symmetry because it is a mirror image of itself on both sides of that line. Vertex. I've used this word, but let's take a look at what it means in terms of our graph. Our vertex is this particular point right there. I'm going to switch to blue. That is the vertex of my graph. Here's the vertex of my second graph. The vertex can be more specifically called a minimum or a maximum. Minimum means it is the lowest point on the graph. So as you'll see in my first parabola, that vertex is a minimum because it is the lowest point. In my second parabola, we'll go to orange here, I have a maximum. My vertex is a maximum because it is my highest point of my graph. So some important vocabulary that you need to recognize: axis of symmetry, vertex, minimum, and maximum. We will use these words quite frequently throughout this unit. Let's review what we've done in the first couple videos. Let's look at the equation y equals 3x squared plus 2. So my question is, does the parabola reflect over the x-axis? And the answer to that is no, because there is not a negative out in front. Does the graph shift? And the answer to that is yes, because we are adding or subtracting something behind here. Because it is a plus 2, we are going to shift up. Does the graph become narrow, wide, or the same as y equals x squared? Because what I'm multiplying the x squared by is greater than 1, that means my graph is going to be narrow. So they ask us to sketch the xy axis We're going to first sketch y equals x squared. It's asking us to sketch, so I don't need tick marks in there. I don't need specific tools or have to be exact, but I do know it is a parabola that passes through 0, 0. From that, let's use the above information to sketch y equals 3x squared plus 2. It does not reflect over the x-axis. It is shifted up 2, and it is more narrow. Next, they would like us to label some of the vocabulary that we learned up above. First off, labeling the axis of symmetry. I said I was always going to use red for that, and we're going to use a dashed line. So there is my axis of symmetry. My vertex. Okay, my vertex is located right here. Okay, I'll call that my vertex, and the coordinates of that are 0, 2. And then they've asked us to state whether it is a maximum or a minimum. Is it the lowest point on your graph or the highest point? Because my parabola opens up, it is the lowest point, which makes it a minimum. Let's talk some more vocabulary. X and Y intercepts. We've already talked Y intercepts this year. Let's talk a little bit more about X intercepts along with Y intercepts. An X intercept is where the parabola crosses the X axis. The graph on the right is asking us to label the intercepts. So let's look at our X intercepts. Okay, where does my graph cross the X axis? Here is my X axis, so I have 2 points that are X intercepts. Right there and right there. When they want us to label them, that means they want us to label the coordinates. The coordinates of the x-intercept on the right, 4, 0. The coordinates of the x-intercept on the left, -2, 0. One thing that's always true about the x-intercepts and the coordinates, the x value is first, my y value is always 0 when I'm talking about my x-intercepts. Now let's talk y-intercepts. A y-intercept is where my parabola crosses the y-axis. My graph has one y-intercept a y-intercept has the coordinates of a x value of 0, and then our y value at the value where it crosses the y-axis. So in this particular point here, we can see that it crosses the y-axis at -8. So the coordinates are 0, -8. Down below the graph, it asked us to label the intercepts. I've labeled the 2 x-intercepts of this graph, the y-intercept, and note that graphs may have no x-intercepts, 1 x-intercept, 2 x-intercepts. Y-intercept you will just see occur once. Axis of symmetry, as I said, I'm using red, and my axis of symmetry is a vertical line. Okay, vertical line, so I'm going to use that point right there and mark my axis of symmetry. Let's come up with the equation for our axis of symmetry. As you can recall from earlier in the year, we talked about the equations of vertical lines and horizontal lines. This is a vertical line. Vertical lines are in the form x equals some number. I take a look at where this vertical line crosses my x-axis because it crosses at 1. The equation of my axis of symmetry is x equals 1. Last but not least, let's label our vertex. Our vertex goes right through our axis of symmetry. The coordinates of my vertex are 1, -9. By chance, do you notice something about our axis of symmetry in our vertex? I wonder if that's coincidence. Last but not least, let's talk about whether our vertex is a minimum or a maximum. Because my parabola opens up, this particular point, my vertex, is the lowest point of my graph, so it is a minimum.